right, so now that we're doing derivations in SD plus as opposed to SD, we have some new things to work with, and I wanted to talk about the new rules of inference very quickly. These are just like the old rules of inference that you've been working with. You basically have, if as long as you have two things, for each one of these, desiderata, two things are required, you can infer the third thing, right? So for each of these, there's two necessary ingredients, and then you can make that inference. So for a modus tollens, that's the one. That's the one I want to go over. It's very important that you recognize that essentially, so that's a bold, by the way, essentially any sentence whatsoever where the main operator is a horseshoe, essentially any conditional, that means, plus the negation of the consequent counts as a modus tollens if you infer the negation of the antecedent. So you can see here, the Q is, as long as that sentence is basically identical plus a tilde in the, as the new main operator, then you can basically copy and paste this, bring it down here, add a tilde. So what I want to do is kind of, go over one of these just to kind of, make sure you see what it looks like. Obviously, if we were to just make, instead of meta variables, the bold P's and Q's, those are called meta variables because they stand for basically any truth functional compound, any sentence whatsoever. But let's make it a little more complicated. This could be just as simple as if A, then B, right? Not B, therefore not A. That's kind of, easy to see. How about this one? L or M, then O triple bar P, right? And then negation of O triple bar P, therefore the negation of L wedge M. So this here again is a modus tollens. Whoops. Notice the main operator here is a conditional, and the main operator here is a negation. And so that means that this sentence just is, actually, I guess it's number one over here. And this one just is number two right there. It's a conditional and the negation of the consequent. And hence you can infer the negation of the antecedent. So I'll do the negation and antecedent and, the antecedent and consequent in different colors. Sorry, technical glitch there. But there it is, the antecedent there without a negation, and over here with a tilde. And the same thing over here for the consequent. You're literally just copying and pasting. So you want to make sure you recognize that P, Q, right? These don't have to be just a single letter. It could be an entire truth functional compound like this disjunction, this biconditional. It could be longer than that. I mean, technically, if I were to have, a string of sentence constants and operators over here, and another one over here, as long as the main operator is still horseshoe, and then in the second line, it's still a negation of whatever's to the right of the horseshoe, it still counts as a modus tollens. So you have to be able to recognize those. Okay, now I want to talk about the replacement rules. Now, there's two things I want to talk about in here in particular. Number one is, remember that they go both ways. So you can go from the left part to the right part and from the right part to the left part. So this hasn't happened before. With the rules of inference, you basically need the two necessary ingredients before you can make that inference, right? So for a modus tollens, which we just talked about, you need that conditional and you need the negation of the consequent to infer this here negated antecedent. That doesn't happen with replacement rules. So you can actually go in either direction, and you can even use replacement rules within certain sentences. So we'll talk about that in a second. But the second thing I want to say before we actually get into using replacement rules within greater sentences is that the way you want to think about it, at least the way I kind of learned it, was that now you're looking at two, typically in many cases, two operators. And for example, let's just look at, for a second, this is called, by the way, De Morgan's, DM. So De Morgan's is going from left to right. It's essentially moving from a negated conjunction. So you can see the main operator here is the tilde. So ultimately, this whole statement is a negation. But the second biggest operator is the ampersand. So this is a negated conjunction. That's kind of the way you should start to think about it. And then what you end up producing is, well, the main operator here is a wedge, right? So that's a disjunction ultimately. But then there's a second biggest operator in this disjunction. It's actually the tildes. They're tied for second place. So the way you really want to look at this, I think, is in terms of not only the main operator, but also the second largest operator. So let's take a look at, I mean, here's an obvious example, right? If you want to make it really simple, if you just take that, you can easily go from that to that, right? I mean, that's basically that P just becomes an A. But let's look at something more complicated. I think people kind of lose, sight of how even a big long sentence technically can still have De Morgan's applied to it, because it really is just, as we've been saying, a negated, conjunction. So how about this? How about we begin with a negation, and let's use brackets here because it's going to be a long one. Okay, so here is a nice, long, complicated sentence. Notice, so let's start figuring out some operators and their scope. Notice that ultimately in this one, the main operator will be a negation. That's the one with the greatest scope. And the second largest operator is this here, ampersand. That has basically everything within the bracketed statement as part of its scope. So because it's a negated conjunction, we can actually do De Morgan's on this. So let me take a second here to write this out. Okay, so here is the statement that I've transposed now. So basically I've gone from a negated conjunction to, well, the main operator in this one happens, well, let's do the same thing we did earlier. Here's two pretty small operators. The horseshoe is a little bit bigger. The negation is bigger still. But the wedge is the biggest of them all. So we went from a negated conjunction to a disjunction of two negations, right? So here, that big old statement right there, it just got moved over here, and we slapped a tilde on it right here. And this statement over here, that just got moved down here, and we also slapped a tilde on it. So the way sometimes maybe I like to think about this is that the process of De Morgan is distributing the negation, right, from left to right, from here to here. You distribute the negation into the conjunction. So as you're doing that, each thing gets changed. So this statement gets a, so let me use red here for a second. As you distribute that tilde into the statement, this thing gets a tilde, this thing gets a tilde, and this one actually gets changed into a wedge. That's the effect that the tilde has when it's being distributed in. So I know it's a big, long, complicated statement. I recommend you look at this again. I mean, this is the kind of the idea behind De Morgan's. You can really do a lot with it, even when it looks like it doesn't apply. So De Morgan's is a very powerful tool. Let me go ahead and do one more for you. Okay, let's work with implication for a second. This one is, again, a replacement rule, goes both ways. And let's actually work from the right side to the left this time. So ultimately what we're seeing here is the main operator here is a wedge, which means it's a disjunction. But one of the disjuncts is a negation, right? So that's the second largest operator. Now, everything else in between, I mean, anything smaller than that kind of doesn't matter, as long as you understand that it's ultimately a disjunction and one of the disjuncts is negated, namely the one on the left. And this one is kind of a classic conditional, nothing too complicated here. So we can use a simple example that we've been working with. Obviously this can be turned into this. A simple application of implication shows that, right? It's just, it's kind of obvious, right? This one is that one, and this one is that one. So let's do maybe a more complicated example. Again, it's very straightforward in that it's just a disjunction and one of the disjuncts is negated. So how about this? Let's do L or M here as one of the negated disjuncts. And then over here, we'll have a big string. It doesn't matter. Let's do... Okay, so ultimately, just to make sure everyone's on board here, this is a negation here. Here is a gigantic conjunction, but the main operator is their wedge. Okay, so how would we do or apply implication to that? Well, essentially what you have to do is, as you're transitioning from this side to that side, what you do is turn the, I kind of like to think of, tipping over this wedge. It just gets tipped over into a horseshoe, but that process puts a tilde or it gets rid of it, makes the tilde fall off or something. I don't know. That's kind of the way I used to think about it. So the first thing we do is turn that wedge into a horseshoe. Now the Q gets carried down. Everything stays the same on the right side. Nothing changes. Copy and paste. But as the wedge tips over, the tilde falls apart for some reason, or falls off. So that's all we're left with, L or M, then that long conjunction. So that's a simple implication, right? So it doesn't have to be as straightforward as just single letters on each side. It can be more complicated like that. So I hope that helps.